everybody, this is example 1 of our composite volume notes. Composite is a fancy word for more than one shape put together. So if we look at this example, let's go ahead and read it real quick. It said Hunter bought an automatic bottle feeder for his cats. Let's go ahead and change that word cats to dogs, because I know right now he has more dogs than he can handle. A diagram of the bottle is shown below, but in mine it's to the left. What is the maximum amount of water that the bottle can hold? So the first thing you want to do whenever you're working with composite volume is figure out what shapes to put together to make that shape or solid. So if we break it apart, this blue piece I'm going to do right here is a cylinder. And then if we identify the rest of the solid, the pink part right here, oh, that was a terrible oval, is a cone. So we have a cylinder. And we have a cone put together to make this bottle feeder. So we're going to go ahead and start our calculations. So the hard part about this is you have to remember each of the volume formulas or look them up in your notes. So remember, volume of a cylinder, we're stacking a bunch of circles on top of each other. So it is the area of one circle, so pi r squared, and then times the amount of circles you stacked on top of each other, which is h. So pi r squared times h. So we have pi, and then our radius would be half of the 6.5, so 3.25, times our height of just the cylinder. 12.5 is the height of the whole thing. 8.5 is the height of the cylinder. So times 8.5. You have to really pay attention to your labels on these. So then I'm going to type that into a calculator, and I get 76.5 cubic inches, and that's just for the cylinder part. Water can also go into the cone, so now I have to calculate the volume of the cone. Cones, remember 3 cones whenever we dumped them in with the M&Ms, 3 cones fit into a cylinder. So my volume formula is the same as the cylinder, pi r squared h, if I divide it by 3. So I have pi r. It doesn't look like we know the radius of the cone, but look here, we know the radius of the cylinder, and this is the base of the cylinder, which would be congruent. So they would have the same radius. So our radius would still be the 3.25. And then the height of our cone, so from the tip straight up, I'm not given that distance, but I do know that the whole thing is 12.5, and this part of it right here, just the cylinder, is 8.5. So to get from 8.5 all the way down to the rest of my 12.5, I could take 12.5 minus 8.5 to figure out what distance is left for my cone. So whenever I subtract those, I get 4 inches for the height of my cone. 4 plus the 8.5 would give me a total height of 12.5. So 4 is the height of the cone divided by 3. Type that into my handy dandy calculator, and for the volume of the cone, I get 167.5 cubic inches. Now the volume would be both the cylinder and the cone put together. So the total, and that's why it's called composite, is it's more than one put together, or more than one taken out, which we're going to do that next. So cylinder plus the cone equals 76.5 plus did not write that number down right. It is not 167.5. I was like, there's no way the cone is bigger than the cylinder. I am so sorry. Go back up to the cone. Type that number into your calculator again. Make sure you check all my numbers that I type into the calculator. Whenever you type that into the calculator, you should get 37.68 inches cubed. Sorry about that. Always double check and follow along with the videos and make sure you type it into the calculator. Plus 37.68. When you add those together, you should get 114.18 cubic inches. And that's how you find the volume of a composite solid. Make sure you break apart what your solids are, find the volume of each, and then put them together. I hope this was helpful. Shoot me some questions if you have any. Also, make sure you follow along with your calculator, and have a great day.